This technique is called electrical resistivity tomography, and it is relatively similar to the 1D resistivity array that we already have shown you in a different video. In this technique, we are building up a 2D cross-section of how resistivity in the subsurface looks as it opposed to a 1D vertical sounding, sort of like a borehole. The setup requires unwinding this cable with equal breakout points and placing electrodes every 1 meter into the ground, and even spacing is important. Here we have 25 electrodes in our survey. Try and make sure that each electrode has a good connection to the soil, but we will check this later. The wire plugs into the geopulse, which has an internal battery and will process a signal. Also connected to the geopulse is a Raspberry Pi, which has its own battery and keyboard for easy navigation. You could do this technique manually, but using the Raspberry Pi has a piece of code on it which will considerably speed up the process. When we turn on the geopulse and the Raspberry Pi, the first thing to do is check that each electrode has a good connection to the ground. The Pi has an automatic process for this. The Raspberry Pi will tell the geopulse the best electrodes to put a current through to check the connection. This brings up a screen on the Raspberry Pi showing the electrode we are waiting to test, the number of cycles or repeats, the electrodes used to take the reading, and an error. We want to check through every electrode for any anomalous readings and reposition that electrode or add water to the ground if needs be. Once we have checked the connectivity, we are ready to start the survey. Again, the Raspberry Pi will automate this for us. This technique works by taking a lot of individual Venner alpha resistivity readings, which we then combine into a 2D cross-section. The first reading is taken using electrodes 1, 2, 3 and 4, which will give us shallow resistivity readings between electrodes 2 and 3. The next reading is taken using electrodes 2, 3, 4 and 5 to give a reading between electrodes 3 and 4. This is repeated all of the way down the line. When we have completed the shallowest readings, we increase the spacing between the electrodes to increase the depth of penetration and then repeat. So this time we are using electrodes 1, 3, 5 and 7 to take a deeper reading around electrode 4 and then moving to use electrodes 2, 4, 6 and 8. We continue this process of taking readings along the right line and increasing the spacing until we have built up a triangular cross-section of the subsurface. The readings on the Raspberry Pi show us the measurement number, the number of cycles or repeat readings, the electrodes being used for the current and potential, C1, C2, P1 and P2, the reading and the percentage error. All of this information will be processed in a computer lab later.